Hi students, welcome back. In this video, we are going to solve all the PYQs from Matrices and Determinants in the JEE, which was conducted from Jan 22 to Jan 29, 2025. So in this question, A is a matrix, 2 by 2 matrix, and look at this Cij, the cofactor matrix here. So the Cij is summation of aik, ajk, I greater than or equal to 1, j less than or equal to 2, and we are asked to find a into modulus of c. Now let us take A is equal to the matrix 2 by 2 matrix, where A is equal to A11, A12, A21 and A22. Now let us take I is equal to 1 and j is equal to 1. Now this cofactor Cij, C11 can be written as is equal to A11. First let us take k is equal to 1 and then k is equal to 2. So I is equal to 1 here. We have taken I is equal to 1, k is equal to 1, j is equal to 1, k is equal to 1. So A11 and A11 plus next A 1, 2 into A, j is 1, k is 2. Now, what is this sum of? We have learnt the product, or we have learnt that if A is a matrix, the sum of a row and a product of here, the product of a row and its cofactor row is equal to sum of the elements will be is equal to determinant of A. Next let us take I is equal to 2, I is equal to 1 and j is equal to 2. K can be taken as the previous step, k is equal to 1 first and then 2. Then the cofactor C12 will be is equal to A1, A11, I is equal to 1 and k is equal to 1, and A21, j is equal to 1, k is equal to 1 plus A12, that is I is equal to 1 and k is equal to 2 into its cofactor, that is j is equal to 2 and k is equal to 2. Now the sum of product of any row with its any other row of the cofactor is equal to 0. Similarly, the next one, taking I is equal to 2 and j is equal to 2, we see what is C22, which is equal to A21 plus A22 and A22. This is equal to, again, this is equal to determinant of A. Therefore, now coming will be is equal to determinant of log 128 is 2 power 7 to the base 5 into log 5 to the base 4. Second row, log 8 can be written as 2 cubed to the base 5 log 5 square to the base 4. Now expanding the determinant, this can be written as this is equal to log 2 to this is 7 log 2 to the base 5 into 2 log 5 to the base 4 minus 3 log 2 to the base 5 log 5 to the base 4. Now this can be written as 7 into 2, 14, this is 14 into log. Now this is equal to 7 into 2, 14, 14 minus 3 is 11 log of 2 to the base 5 into log of 5 to the base 4. Now simplifying this can be written as this is equal to 11 log 2 to the base 5 log 5 to the base 2 squared. Now this 2 squared can be written as this is 5 to the base 2. Value of this is 1. Therefore, we got determinant of A is equal to 11 by 2. C11 is determinant of A, C120, C22 is determinant of A. So we can write in general the C matrix will be is equal to determinant of A 0 0, determinant of A which is equal to 11 by 2, 0 0 11 by 2 which is equal to 111 by 2 into 11 by 2 121 by 4. So 4 into C is equal to, therefore C is equal to 121, or 8 into modulus of C will be is equal to 242. So the answer for this problem is 242. The next question, f of x is equal to the given determinant. Find the value of m power 4, maximum value. Then m power 4, capital M denotes the maximum value, small m denotes the minimum value. Here taking the determinant f of x, let us first consider, let us take R1 2 R1 minus R3, let us try. Then similarly R2 tends to R2 minus R3. We'll see what is the determinant we are getting. F of x is equal to determinant of R1 minus R3. So I am going to subtract the first row and the last row. Here the elements so formed will be 1, 0 and minus 1. Similarly R2 minus R3 gives me, this is R2 minus R3. Subtracting the row elements here, sin square minus sin square 0, 1 plus cos square minus cos square gives me 1, and the next element will be minus 1. The last row remains as it is, sin square x, cos square x and 1 plus 4 sin 4x. Now expanding the determinant, expand the determinant along R1. So when we expand along R1, this is 4 sin 4x. Expanding along R1, we get 1 into 1 plus 4 sin 4x minus cos square x. Then here 0 minus of 1 into minus sin square x. So simplifying, we get f of x will be is equal to 2 plus 4 sin 4x. We get f of x here. Now we know that the range of sin x will be 1 less than or equal to sin 4x less than or equal to 1. Now multiply throughout by 4. We get minus 4 less than or equal to 4 sin 4x less than or equal to 4. Similarly, next what we are going to do here, 1 plus 2 is there. So we add 2 throughout. So when we add 2 throughout, what is that we are getting here? We are getting minus 4. Minus 4 plus 2 is minus 2 less than or equal to 4 sin 4x plus 2 less than or equal to 4 plus 2 is equal to 6. Now we see 4 minus, here I'll write here, therefore m power 4 minus m power 4 will be is equal to, where capital M, the maximum value will be is equal to 6 and the minimum value will be is equal to 2. Minimum value is equal to 2, therefore that is 6 power 4 minus 2 power 4 and that is equal to 1280. So our answer is 1280. This is another simple question. Given here s is equal to a power m square plus a power m is equal to 3i minus a power 6, a power minus 6, where a matrix is given, and so here let us find a square and a cube etc. So this is a is equal to 2 minus 1 1 0. We'll find what is a square. A square is equal to 2 minus 1 1 0 into 2 minus 1 1 0. Now when we multiply this first row first column, that will be is equal to 4, the 4 2 into 2 4 minus 1 is equal to 3. Next first row second column, minus 2 plus 0, that is equal to minus 2. Next second row first column we multiply, we get that is equal to 2, and second row second column minus 1. Next we multiply what is a cube matrix. A cube is equal to a square into a, so 3 minus 2 2 minus 1 into the a matrix, that is 2 minus 1 1 0. Now this is equal to first row first column, we get the elements 4 minus 3 3 and minus 2. Similarly, we find what is a power 4. A power 4 will be is equal to 5 minus 4, 4 minus 3. How did I write this directly? And so on it goes on up to a power 6 is equal to 7 minus 6 and 6 minus 5. Now look at all these elements here. Looking at all these elements, this element is 2. Now a square will be is equal to, the first element is 3, a cube first element is 4, a power 4 first element is 5. Therefore, I can write a power 5 first element will be 6 and a power 6 first element is 7. So, the first element in general, how can I write this a power m in general? Any matrix of the form a power n, m can be written as is equal to some m plus 1. A power 2, the first element is 3, a1 element. So, I can write it as am plus 1. The next element is minus 1. For all the elements we get here, the second element to be is equal to minus. This will be is a squared. So this a squared, when it is squared, it is 2, minus 2. When it is cube, it is minus 3. A power 4, minus 4. So in general, this a power m will be is equal to, this element will be is equal to minus m. And the next element on seeing here, we see that a matrix A21 element is 1, A22 element is 2, a cube is 3, a power 4 is 4, a power 6 is 6, and therefore we can write a power m will be is equal to m. The last element 0. The next this will be a square is 0 minus 1, and this is minus 1 minus 1, minus 2 minus 1, minus 4 minus 1, and therefore this will be minus m plus 1, or it can be written as minus of m minus 1. This is equal to, can be written as. Now in general we have got what is a power m. Now let us write what is a power m square. A power m square will be is equal to m square plus 1 minus m square. M in the place of m replaces m square, so minus of m square minus 1. This is a power m square. Therefore, this is a power 6, but in the question we want a power minus 6. Therefore, we can write what is a power minus 6 will be the inverse adjoint of this matrix. I write, so that is minus 5, 6, minus 6 and 7. This is a power minus 6. Now we are going to find what is 3i minus a power 6. Then 3i minus a power 6. Therefore, a power m square plus a power m is equal to 3i minus a power minus 6 can be written as, this will be is equal to a power m square is m square plus 1 minus m square and minus of m square minus 1 plus a power m can be written as a power m, which is m plus 1 minus m and minus of m plus m minus of m minus 1. Now right hand side, this is equal to 3 into I 1001 minus a power 6, a power minus 6 minus 5, 6 minus 6 and 7. Now we add both the sides. We add the first element here, m square plus 1, m plus 1, so that is m squared plus m plus 2, which is equal to the first element. This is 3 plus 5, which is equal to 8. So now this can be simplified, which can be written as is equal to m square plus m minus 6 is equal to 0, or m is equal to minus 3 comma 2. So here m cannot be negative, therefore we take n of s is equal to 2. Number of elements in the set can be taken to be is given as a square is alpha plus beta root 2. Then we find what is alpha beta, and then alpha plus beta is equal to, we have to find. So here let us take a matrix will be is equal to a root 2 whole power I plus j. So root 2 whole power 1 plus 1 will be root 2. root 2 whole power 1 plus 2, A12 element will be is equal to root 2 whole power 1 plus 2 will be is equal to 3. Next, root 2 whole power 4. The next element will be root 2 whole power 3, root 2 whole power 4, root 2 whole power 5, and root 2 whole power 4, 3 plus 1, 4. The next element will be root 2 whole power 5 and root 2 whole power 6. Now this matrix can be rewritten. This is equal to 2, 2 root 2, 4, 2 root 2, 4, 4 root 2. Next is 4, 4 root 2 and 8. Now we find what is, here 2 is common for all the elements. It can be written as 2 times of 1, root 2, 2, root 2, 2, 2 root 2. Here this is 2, 2 root 2 and this is 4. Now we find what is A square. A square will be is equal to 2 square, that is 4. 4 into, I multiply this matrix twice, A square, the third row of A square. I want only the third row of A square. So that is 4. First 2 rows we multiply, next 2 rows we multiply. Now I want the third row. Last row, first column we multiply. So last row, first column will be 2 into 1 is 2 plus 2 into 2, that is 4, plus the next element 4 into 2 will be is equal to 8. We have multiplied the first element. Last row, second column, 2 into root 2, 2 root 2, plus 2 into 2 root 2, 4 root 2, plus 4 into 2 root 2 will be 8 root 2. The next element will be is equal to, last row, last column element, that is 2 into 2 is 4, plus 2 into 2, 4 into root 2, that is 8, plus the next element 4 into 4 is 16. So we want the third column elements we have found. So sum of the elements of the third row will be is equal to, sum of these elements 14, sum of these elements will be 14 root 2, sum of the elements will be is equal to 28. Now we take the sum of elements of the third row. That will be is 4 into, so this is equal to 4 times of 14 plus 14 root 2 plus 28, which gives us, this is equal to 4 into 4, 8 plus 14 into 4, that is 56 root 2. Now compare this value with what is given in the question. So compare with the elements, that is alpha plus beta root 2. Compare this with alpha plus beta root 2. So when we compare, we get, compared with alpha plus beta root 2, therefore we get alpha is equal to, alpha will be is equal to 168 and beta is equal to 56. Now our aim is to find the value of only alpha plus beta. Alpha plus beta is equal to 168 plus 56, which is equal to 224. Moving on to the next question, we have 3 equations here and it has infinitely many solutions. Then find the value of sigma n power alpha plus n power beta. We take delta is equal to, from the 3 given equations, the coefficients 1, 1, 1 in the first equation. Next equation, x, coefficient of x is 0. The next equation, the coefficient of x is 1, 2 and 4. The third equation is 1, 4 and 10. Expanding the determinant, that will be is equal to 1 into 20 minus 16 minus 1 into 10 minus 4 plus 1 into dz is equal to 0. Here I take d3 is equal to 0. What is d3? d3 will be is equal to 1, 1, 1, 1, 2, 4, and in the place of the coefficient of ez we replace by the elements, that is 1 m and m squared. So that will be 1 m squared. This is d3. Taking d3 is equal to 0, we get, expanding the determinant, equating it to 0, we get this is equal to 0. Expanding, we get, that is m squared minus 3x plus 2 is equal to 0, which gives us m is equal to 1, 2. Here we take, that is, we take alpha is equal to 1 and beta is equal to 2. So alpha and beta are known to us. Now we are going to find what is sigma of n power alpha, n power beta. Therefore, sigma n is equal to 1 to 10. N power alpha, alpha is 1 plus n power beta, beta is 2 here, which can be written as this is equal to sigma n is equal to 1 to 10 n plus sigma n square formula n into n plus 1 into 2n plus 1 by 6. So we get here 10 into 11 into 2n plus 1, that is 21 divided by 6. So here 6 and 21. So 2 times. Now this will be is equal to 55 plus 385, which is equal to 440. So our answer is 440 here. Now looking at this question, a matrix is given to us and it is given that we can write here orthogonal P is orthogonal P, P transpose will be is equal to I. Orthogonal matrix, it is an orthogonal matrix. Therefore, given here this B is equal to P A transpose and C is equal to P transpose B power 10 into B. Therefore, I write here C is equal to P transpose B power 10 into P, which is equal to B transpose. This B power 10 can be written as P transpose into P transpose 10 times. So P transpose into P. Now we know that P transpose into P is I. P transpose into P is I. Again, so P transpose into P is I. The last one, P transpose into P is I. The number of times we get A, so that will be is equal to A power 10, and so we got C is equal to A power 10. Now we come on to this A matrix. What is this A matrix given here? A is equal to matrix 1 by root 2 minus 2 0 1. We find what is A square here. A square matrix will be into 1 by root 2 will give us is equal to 1 by 2. First row second column gives us minus root 2 minus 2. The next element is 1 and the next element is 0. 0 into the number gives us 0. Last element is 1. This is A square. We find what is A cube. All these elements. So comparing, we know that C is equal to A power 10. So see the elements of the diagonal here. We want the sum of the diagonal elements, and so here the sum of the diagonal elements. The question is the sum of the diagonals. So here sum of the diagonal elements. So here that is A, so 1 by root 2 plus 1. A square is 1 by 2 plus 1. A cube is 1 by, sum of the diagonal is 1 by 2 root 2 plus 1, and so on. Therefore, in general, what we get A power 10. We want A power 10. A power 10 will be is equal to 1 by root 2 whole power 10 plus 1, which is equal to 1 by 32 plus 1, which is equal to 33 by 32, which is of the form m by n, where the GCD is equal to 1. Now we want to find, or we can take that, we can compare and tell m is equal to 33 and n is equal to 32, and therefore m plus n will be is equal to 33 plus 32, which is equal to 65. Answer is 65. Two equations are given. Then determinant of edge of 2 times of a plus I is equal to 2 power alpha, 3 power beta, 5 power gamma. Then find the value of alpha square plus beta square plus gamma square. So here given X matrix is equal to X, Y, Z. Therefore X transpose will be is equal to X, Y, Z. Now let us take X transpose A X is equal to 0. Therefore X transpose is X, Y, Z into A matrix A1, A2, A2 matrices. Therefore, we get X, Y, Z into the matrix. We get A1X plus A2Y plus A3Z. Next, B1X plus B2Y plus B3Z. Next, C1X plus C2Y plus C3Z. This is equal to 0. Take the product of the first two matrices and we get X into A1X plus A2Y plus A3Z plus Y into next B1X plus B2Y plus B3Z plus Z into C1X plus C2Y plus C3Z is equal to 0. So here x1 square A1 x1 squared B2 y2 y squared C3 z square is equal to 0. Therefore, we can write A1 is equal to 0, B2 is equal to 0 and C3 is equal to 0. Then equate the coefficients of x terms. We get that is equal to A2 xy plus B1 xy, A2 xy and B2 xy, xy terms. So A2 plus B1 is equal to 0. Similarly, xz terms, taking the xz terms, A3 xz plus C1 xz. So we get A3 plus C1 is equal to 0. Next, B3 yz. Here we take B3 yz. This is B3 yz. And here C2 yz. So here we can write B3 plus C2 is equal to 0. These terms A1 in a matrix, A is a 3 by 3 matrix, A is equal to A1 is 0, B2 is 0, C3 is 0 here. Therefore, it is a skew symmetric matrix. It can be said as A is a skew symmetric matrix. Therefore, we can write A as given A into the matrix 1 1 1 is equal to 1 4 minus 5. Therefore, which implies A matrix is 0 xy minus x 0 z minus y minus z 0 into the A matrix, that is 1 1 1, will be is equal to 1 4 minus 5. Now multiplying these matrices and simplifying first row first column, second row column and the third row column, we get the equations x plus y is equal to 5. So these are a set of equations. First set of equations, we have it as equation number 1. Next, it is also given that in the question, let us see what is given. It is given in the question that the second equation, that is A into the matrix 1 2 1 is equal to 0 4 minus 8. Therefore, I write it as this is right hand side is 0 4 minus 8. So we get the equation as 2x. The next set of equation will be 2x plus y is equal to 0. So I can write the equation 2x plus y is equal to 0. The second equation will be minus x plus z is equal to 4. And the third equation can be written as minus y minus 2z is equal to minus 8 will be the second set of equations. Now solving these two sets of equations, solving equations 1 and 2, we are going to get the value for x, y and z. So solving equations 1 and 2, we get x is equal to, solving equation, we can write the skew symmetric matrix A, substitute the value for x, y and z. We get 0 minus x is, the x is minus 1, y is 2, minus x is 1, 0, 3. Next element, minus 2, minus 3 and 0. This is the matrix, skew symmetric matrix A. But here, what is the question we have to find here? Determinant of Adj of 2 times of a plus I is equal to 2 power alpha, 3 power beta and 5 power gamma. Therefore, we are going to find what is a plus I. This is a matrix. I can write a plus I. A plus I will be is equal to 0, minus 1, 2, 1, 0, 3, minus 2, minus 3, 0 plus I matrix, that is 1, 0, 0, 0, 1, 0 and 0, 0, 1. Add these two matrices, we get a plus I. A plus I will be is equal to 1, minus 1, 2, 1, 1, 3, minus 2, minus 3 and 1. Now 2 times of a plus I, therefore 2 times of a plus I will be is equal to the matrix 2, minus 2, 4, 2, 2, 6 and 2, minus 6, 2. This is 2 times of a plus I. Now our aim is to find determinant of adj of 2 times of a plus I. Suppose I take this as matrix B. This is 2 times of a plus I is equal to B. This is determinant of adj B, which is equal to determinant of B the whole square. Therefore, I can write 2 times of a plus B as B. Therefore, determinant of B will be is equal to determinant of 2 minus 2, 4, 2, 2, 6, 2 minus 6, 2, which is equal to 2 times of 4 plus 36, which is equal to the determinant of adj of B, which is equal to modulus of B squared. So modulus of B squared will be is equal to this determinant of B squared will be is equal to determinant of 120. Determinant of B is 120, so we get 120 whole square. Now take this 120, see the question can determinant of adj of 2 times of a plus I is equal to 2 power alpha, 3 power beta into 5 power gamma. Now therefore, determinant of B we know is equal to 120 whole square, which can be written as 120, 60, next 2 times 30, 2 times 15, 3 times 5. So I can write this 120 as 2 power 3 into 3 power 1 into 5 power 1 whole square, or this is equal to 2 power 6, 3 power 2 into 5 power 2, and therefore compare this value with 2 power alpha, 3 power beta and 5 power gamma. Therefore alpha is equal to 6, beta is equal to 2 and gamma is equal to 2, and alpha square plus beta square plus gamma square will be is equal to 36 plus 4 plus 4, which is equal to 44. The next question, f of x is the given determinant, limit extends to 0, f of x is equal to, compare it with lambda plus mu a plus 1. So here limit of f of x, limit extends to 0, f of x, the determinant becomes limit extends to 0 of f of x will be is equal to determinant of a plus 1, 1, b, a, 1 plus 1, next b, a, 1, b plus 1. Now let me make the transformation here, r1 to r1 minus r2, and I'm going to transform r2 to r2 minus r3. So the determinant so formed will be determinant 1 minus 1, 0, 0, 1 minus 1, and the last row becomes a1 b plus 1, and again let me transform c2 to minus c2 plus c1, or we can write it as c1 minus c2. The first column remains the same, 1 0 a, second column is 0 1 a plus 1, the last column is 0 minus 1 b plus 1. Now this expanding the determinant, we get this is equal to, so 1 into b plus 1, 1 into b plus 1 plus 1 into a plus 1 minus 0. Now this we equate to the right hand side, which is equal to lambda plus mu a plus mu a, mu into b. So now this is equal to lambda plus mu a plus mu into b, which implies a plus b plus 2 is equal to lambda plus mu a plus mu into b. Comparing the terms, we get here lambda is equal to 2, mu is equal to 1 and mu is equal to 1. Therefore, lambda plus mu the whole square will be is equal to 2 plus 1 the whole square, which is equal to 16. The next question, another simple question. 3 equations are given, has infinitely many solutions. Then mu minus 2 lambda is equal to dash. So here we find first to say that the given system of equations has infinitely many solutions. If this dy dz is equal to 0, or we can say that is delta x or dx or dz. So I can write here delta x is equal to delta y is equal to delta ez is equal to 0. 3 equations are given. Let me take that delta ez is equal to 0. Therefore, delta ez will be is equal to 2, 5, 100. Coefficient of x first column, coefficient of y in the 3 equations minus 1, lambda minus 47, and the constants here in the third column 4, 12 and 212. x2 424 lambda, 2 into 564, that is plus 1128, minus this term will be is equal to plus, this will be minus. So the next term is minus 140 and the next term is minus 940 minus 400 lambda, equating to 0, which implies this delta is equal to 0. Delta z is 0. So equating this to 0, we get the value for lambda. Lambda is equal to minus 2. Equating to delta is equal to the coefficient of the x terms to 500, coefficient of the y term is minus 1, lambda is minus 2 and minus 47. Z coefficient 1, 3 and mu. Equate delta to 0, which implies 2 times of minus 2 mu plus 141, 3 into 147. So 141 plus 1 into 5 mu minus 300 plus 1 into minus 235 plus 200, equating this to 0, we get mu is equal to 53. So lambda is equal to minus 2, mu is equal to 53. Therefore, mu minus 2 lambda becomes is equal to 53 minus 2 into minus 2, which is equal to 53 plus 4, which is equal to 57. So mu plus 2 lambda is equal to 57. Then the inverse of this term is equal to dash. So here A into adjoint of A inverse plus adjoint of B inverse whole inverse into B. We have to find the inverse of this term. So we know that reversal law, AB whole inverse is equal to B inverse A inverse. We are going to use this here. So AB whole inverse is equal to B inverse A. We can write B inverse into adjoint of A inverse plus adjoint of B inverse into A inverse, applying the property. AB whole inverse is equal to B inverse A inverse. So now again this can be multiplied inside. So we can write again this as B inverse. Now I can write this as B inverse edge of A inverse plus into this A inverse plus B inverse into adjoint of B inverse into A inverse. Now next step, Again we know that A into adjoint of A is equal to adjoint of A into AI. So in the place of A, I have A inverse here. Adj of A inverse can again be written as this is B inverse into adj A into A is determinant of A. Here in the place of A we have A inverse. So B inverse A inverse into I. Similarly, here in the place of B inverse, we can give adj B inverse into B inverse can be written as this A inverse I write here, and though this will be B inverse determinant of B inverse into I into A inverse. We are using this property here. Now, next step, this A inverse into I can be written as B inverse determinant of A inverse into I can be written as determinant of A plus similarly determinant of B inverse into I, this A inverse I write, so this is A inverse divided by determinant of B. What is missing here? Modulus of B. Determinant of B is missing, so I write B inverse by determinant of A into modulus of B by modulus of B. For the next term, A inverse by determinant of B into determinant of A divided by determinant of A. We know that B inverse is equal to 1 by determinant of B into adjoint of B. Therefore, again using this property here, what are we doing? B inverse into determinant of B. B inverse into determinant of B can be written as this is equal to adjoint of B. This can be written as adjoint of B by determinant of B into determinant of A. Similarly, the next term can be written as adjoint of A divided by determinant of A into determinant of B, which is equal to 1 by determinant of A determinant of B into adj B plus adj A. Next, another simple question. 3 equations given, they have infinitely many solution. Find lambda square plus lambda. For infinitely many solution, let us take delta or D is equal to the determinant lambda minus 1, lambda minus 4, lambda from the first equation, second equation lambda minus 1, lambda minus 4. Third equation, we get the coefficients lambda plus 1, lambda plus 2, minus of lambda plus 2. Now equating this to 0, we make the transformation with R1 to R1 minus R3 and R2 to R2 minus R3. What is the determinant we are getting? This is equal to determinant of minus 2, minus 6, lambda minus 4 minus lambda plus 1. So we get that is minus 6, 2 lambda plus 2. We have added R. Now R2 minus R3, we get minus 1 minus 3, 2 lambda minus 2, lambda plus 1, lambda plus 2, minus of lambda plus 2, determinant equal to 0. Now multiply R1 and R2. Multiply R1 and R2 by minus 1. So we get the determinant, that is 2, 6, minus of 2 lambda plus 2. 1, 3, 2 minus 2 lambda, lambda plus 1, lambda plus 2, minus of lambda plus 2. So now equating this to 0, equate the determinant to 0, we get the factors lambda minus 3 into 2 lambda plus 1 is equal to 0, which implies lambda is equal to 3 and lambda is equal to minus 1 by 2. Here lambda cannot take the value minus 1 by 2. Therefore, we take the value lambda is equal to 3 here. So taking lambda is equal to 3, we get taking lambda is equal to 3. Therefore, lambda square plus lambda gives us 3 square plus 3, which is equal to 9 plus 3 is equal to 12. Lambda plus lambda square is equal to 12. Next, another simple question. The system of equations has no solution. Then among these, find the correct answer for lambda and mu. So taking it has no solution, therefore we take d will be is equal to determinant of 1, 1, 1, 1, 2, 5, 1, 5 and lambda. Equating this to 0, we get 1 into 2 lambda minus 25 minus 1 into lambda minus 5 plus lambda into plus 1 into 5 minus 2 is equal to 0. Equating to this to 0, we get lambda is equal to 17. So here the lambda is equal to 17. So here from the options we can find out that lambda is not equal to 17 is not the answer. Lambda is equal to 15 is not the answer. So either 1 or 4 must be the answer. Now next equal to 0. So expanding the determinant, we get that mu is not equal to 18. So our answer is lambda is equal to find here. So let us take A is a 3 by 3 matrix. Therefore A is equal to, we can take the elements to be A, B, C, D, E, F and G, H, I. Now given first A into the, take the first equation, therefore we write given A into the matrix 0, 1, 0 is equal to 0, 0, 1. So A matrices A, B, C, D, E, F and G, H, I into the matrix 0, 1, 0 is equal to 0, 0, 1. So multiplying both the matrices, we get the elements are, we get B is equal to 0. Multiplying the first row in the column, here B is equal to 0 and we get E is equal to 0 and H is equal to 1. These are the first set of elements here what we have got. Next, similarly we consider the second equation, where the second equation and one more equation is there. We take the second set of elements here. Therefore again it is given that A into the matrix 4, 1, 3 is equal to 0, 1, 0. So we take A matrix, the 3 by 3 matrix what we have taken, A, B, C, D. Here this is equal to 4A plus B plus 3C. Substitute the values of B, E and H here. B 0, E 0, H 1. B 0, E 0 and we get H is equal to 1. So we have substituted, therefore now the simplified equation becomes 4A plus 3C is equal to 0, 4D plus 3F is equal to 1 and the next equation becomes 4G plus 1 plus 3I is equal to 0. Another set of equations we have got. Now coming to the third equation from the given question, the third equation is A into another matrix is equal to 1, 0, 0. So again we write given A into the matrix 2, 1, 2 is equal to 1, 0, 0 for B, E and H, which is 1 here. So we get the elements to be is equal to 2A plus 2C is equal to 1 and therefore 2D plus 2F is equal to 0 and the next equation is 2G plus 1 plus 2Y is equal to 0. Another set of equations we have got. This equation number 1 and 2. So solving 1 and 2 we get D is equal to 1, F is equal to minus 1. Therefore, I want the element A23 element, where A23 element or 23 element, this is the A matrix, A23 second row, third column element, A23 element is F here, F is equal to minus 1. So we can write A23 is equal to minus 1. The next question, for the set of equations, 3 equations are given. They have infinitely many solutions. Then find the value of 7a plus 3b. The procedure is the same. So for infinitely many solutions, we have delta d is equal to 0, dx is equal to 0, that is dx or d1, delta x or d1, or d2, d3, all the terms are equal to 0, then we have infinitely many solutions. Therefore, we take d is equal to the coefficient of x, y, and z are all the three equations 1, 1, 2, 2, 3, a minus 1, minus 3, and b, and equating this to 0. We get here, simplifying the equation, we get 2a plus b minus 6 is equal to 0. Next, similarly, d1, we find what is d1 here. d1 in the place of the x coefficient, replace the constants in the equation. 6a plus 1, 2b, 1, 3, minus 3, 2a and b. And equating this to 0, we get the set of equations equating to 0. We get here 12a plus 5b plus ab minus 6 is equal to 0. Then similarly, d2, d3 equating to 0, we get, I have simplified the equation determinant already, and I give only the equations here. 1, 2, 3b minus ab plus 2 is equal to 0. And next, d3, equating d3 to 0, where d3 is equal to 1, 2 minus 1, 1, 3. Solving equation 1 and 2, I get a is equal to minus 2 and b is equal to 10. And therefore, 7a plus 3b will be is equal to 7 into minus 2 plus 3 into 10, which is equal to minus 14 plus 30, which is equal to 16. So, we get 7a plus 3b is equal to 16 is the answer.